So our function machine is going to have a few different things. The main thing is you're going to have an input now. This input is always going to be your x. Okay. This function will have a process, and we're going to call this the function of f. And then later on, after it goes through the function, through our machine, you're going to get our output, which is y. Another way to think about this is as a vending machine, right? You press a button, you press a button for water, and you get water, okay? Then if you press the button for Coke, you get Coke. That is a working machine. You press something, there's an input, and there's a specific output, okay? Now, the issue is not every single machine works, not every single equation that you see, it's a function. Because if you press Coke and you get water, and then you press again Coke and you get Sprite, and then you press again Coke and you don't get anything, that machine is not working. Okay? Do you want to use that machine? No. Okay? So we need to be very, very careful with functions. We're going to see different functions that work. So the first one that we're going to pay attention to are graphs. So we're going to write graphs. A coordinate plane is very common to represent graphs. You're going to have different graphs throughout your life, but we're going to be paying attention to the ones that are functions and the ones that are not functions. So the first example, and it doesn't have to be precise, we're going to create this just for future reference, but it won't be in your quiz. This is a cubic function. Now, to figure out if this is a function, the only thing you need to do is follow what we call the vertical line test. The only thing you're going to do is draw vertical lines and see if it touches one or more points. In this case, we're going to drop 1, 2, 3, 4, 5, 6. So you do the vertical line test, and if it only touches one point, it is a function. Now, let's draw another one. If we draw a graph like a sideways U, if you draw vertical lines right here, it touches, we can say 1 point. But if you move a little bit to the right, you can see that in this case it's touching a point right here and also a point right here. So that is not a function because the line touches 2 points. So we're going to label them function, not a function. Again, and the only thing we need to do is whenever you have a graph, draw a straight line. If it only touches 1 point, then it's a function. So for the diagram, we are going to draw 2 ovals. We have 2 ovals, and we're going to put 1, 2, 3 inside, and then we're going to have 0, -1, and 4. The first one is going to be your input or your x's, and then the right ones will be your output. Your y's. If we draw a line to connect these ones, and I'm going to connect them like this, the only thing we're paying attention is one input has only one output. That's it. So we're going to look at number 1. Number 1 connects to 4, so that means that it only has one output. Number 2 goes to 0, has only one output. Number 3 goes to -1, it has only one output. So that is an example of a function. So we're going to write down function. Now, not all the functions will be exactly like that. Then you're going to have some functions such as this one. So we're going to have 3, 4, 8. And we're going to put 1 and 2. We're going to connect the 3 to the 1. We're going to connect the 4 to the 2. And then we're going to connect the 8 and the 1. Again, you have 3 going to 1, which is only one output. You have 8 going to 1, which is one output only. And 4 going to 2. As a bending machine, sometimes you'll see that some of the buttons are going to give you exactly the same result. Usually, a bending machine that sells drinks is going to have a few that are going to be water. So again, you can have different inputs that are going to give you the same output, which is totally fine. So this is also going to be an example of a function. Now, let's look how a diagram that doesn't have a function. So we're going to draw another set of ovals. Now, I'm going to tell you that if you press 1, you may get 3, or you may also get 4. And then when you press 2, you get 8. In this case, you can see again that number 2 goes only to one point in the output column, which is fine. The issue is the 1 can either give you a 3 or can give you a 4, which now has an issue. It's a machine that is not working because it's not being consistent with the things that are going to give you. Now, this is going to take us to the next part, which is a table. So we're going to write table now. So when we're paying attention to a table, I'm actually going to use exactly the same numbers that we already have. Okay, same numbers that we already have. The first one is always going to be your X. The second one is always going to be your Y. So using the numbers from above, you know that if you press 1, you might get a 3. If you press 1, you might get a 4. And then if you press 2, you're going to get an 8. Whenever you have a table and you see that these values repeat and give you a different one, you know it's not a function. Okay? So again, whenever they're giving you a table, you're going to look for the x's and see if they repeat. If they repeat, you already know that it's not a function. Are we clear? The last point that we need to cover are equations. You need to figure out if an equation is a function or it is not a function. Okay? Most of the time, an equation is going to be a function. So there's nothing to be worried about. So let me give you a couple of examples. Functions can look like this. Y is equal to 4. Another example of an equation is y is equal to 3x. Another example of an equation is y minus 1 is equal to 4x. You can even get some funny ones. For example, you can get x is equal to 1 over y. Whenever you have equations like that, you're always going to be getting a function. Okay? So these are examples of all of this are functions. Now, let's go over some that are not functions. So I'm going to cross it out so you know that it's not a function. So right here, we're going to be looking at so if I give you x minus 2 equals to x minus 1. If I give you something like this, it's not going to be a function. Okay, we're not going to get into too many details, but I want to just explain you why. If you remember how to isolate variables, I'm actually going to subtract x from both sides. And now you get negative 2 is equal to negative 1. Since negative 2 is not equal to negative 1, this does not work, so it's not a function. So whenever you have funny cases like those are the ones that you're going to say, okay, it's not a function. But most of the time, you're going to be getting examples like the ones I had above. Most of the time, you're going to be seeing things like this. As long as you see an equation like this, you know that this is going to be a function. And some of them are going to even get more creative, and you're going to have exponents too. And that's totally fine.